Okay, and ladies, it's all yours.
Hi, my name is Heather Pilardi and I work for Eastern Connecticut Conservation District.
I'm Danielle Holmes. I work for Ledyard Health District.
And welcome to Septic Systems Maintenance Talk. And you wanna,
You ready?
yeah,
All right, where are we? What happened to your, oh, there it is, sorry, thank you.
nice.
And where's the,
Right there. Yep.
okay,
Perfect. All right, thank you.
so can everybody see that?
Yes,
Okay, and can everybody hear us? Okay,
Yes.
I'll take that as a yes.
All right.
Thank you, Rick.
So thank you for coming to today's talk. We're doing the septic systems maintenance to benefit water quality. And we want to thank the mayor for having us here tonight. And so let's get started. Eastern Connecticut Conservation District, for those that don't know, we are a nonprofit natural resource conservation organization serving 36 municipalities in Eastern Connecticut. And our focus is on water and soil conservation. So these are our project partners. And I don't know if you are all from Eastern Connecticut, but the yellow part is the whole area that Eastern Connecticut Conservation District serves. This Long Island Sound Future Fund grant was started in June of 2022, and it will end in August this year. So the main things that we're trying to do is create a physical pollinator pathway map. So we're basically planting native species of plants in order to help the pollinators along the city of Groton, the towns of Groton, Stonington, Preston, and Ledyard. And the way we're doing this is in repairing buffers, or what is called vegetative buffers, also rain gardens. And we are to hold 5 workshops and work days. We're putting up signages and brochures and helping get the word out there for people who don't understand how this works. This is to reduce the stormwater runoff, flood control, and to recharge the groundwater. And we want to definitely provide food for the pollinators that are hurting right now. Let's see. And this is all in southeastern Connecticut. So this talk has been funded by the United States Environmental Protection Agency, and it's through the National Wildlife Foundation. It's also part of the Long Island Sound's Future Fund. Our partners include the staff, commissions, and conservation organizations from the city of Groton, and also the towns of Groton, Ledyard, and Preston. So here's some things that you could do to help us in this process. We definitely want to do pesticide-free continuous corridors of native plants. And you can plant small flower boxes. If you don't have a lawn, you can use recycled buckets from, I went to Stop and Shop one time and they have in the bakery, they have the empty icing buckets left over. They'll rinse them out for you. Just drill holes in it and then you can put your own dirt in it and plants. It's pretty cool. So, but you can help. So I think we're going to turn it over to you now. All right.
All right. So this is Danielle here. Hi, everybody. Thanks for joining on Valentine's Day to hear about septic systems. I am a senior sanitarian with Ledyard Health District. Our district covers 9 municipalities all across Long Island Sound, basically from Old Lyme East all the way to Rhode Island. And we have a handful of landlocked towns. My background, I started in public health in 2013. I studied environmental science and policy. And I'm also co-chair for the state's technical advisory committee for subsurface septic systems. So a lot of the day-to-day for me consists of inspections, soil testing, plan reviews, and general enforcement of the state's public health code. Approximately 40% or 1.5 million people in Connecticut are served by a conventional septic system, and they fall within their local health department's jurisdiction. Jurisdictions vary based on design flows. Design flow is particular to a property, so although we regulate almost all single-family residences, we also oversee some commercial activity as well as multifamilies. So the state of Connecticut Department of Public Health, they are the ones who have enacted the health code, and below them are a subset of health districts and departments across the state. Ledyard is a district which consists of multiple towns. Some health districts and departments are standalone. So they only consist of one city. And with regard to design flow, health districts and departments on a local level regulate up to 7,500 gallons per day discharge on one property. From 2,000 gallons to 5,000 gallons, from 2,000 to 7,500 gallons, the State Department of Public Health will have to review and approve those plans for subsurface sewage disposal, and above 7,500 gallons per day is in the jurisdiction of the Connecticut Deep.
It's not, I don't think your slides are showing. Can everyone see the slides?
Are we having a slide issue?
Yeah, because this is what I'm seeing this still,
Oh,
and it's still us. Like you can see.
All right.
Yes, we see the slides.
Well, what slide are you seeing right now?
Septic system maintenance to benefit water quality.
okay. So hang on one moment.
Let's kill that out of the slide.
So we can do,
And you can stop video too. Oh,
okay. We're gonna try this again.
Okay.
This should be a new screen for you.
oh, there it is. Did you want to stop your
How does it look
video?
now?
Yeah.
What is a septic system is what we see now.
Perfect.
Perfect.
Okay, Karen, please
Sorry
have,
about that, guys.
All right. So in general, what is a septic system? We have seriously advanced in the last 100 years from our prior practices. So I have an outhouse pictured here on the screen, which is the most antiquated type of subsurface sewage disposal. From there, we sort of were born into cesspools. They're still considered an antiquated system, although they do exist on some properties still. So subsurface sewage disposal, in general, here's your typical ideal setup. You have your interior plumbing. After the flush, you enter a septic tank. Most modern tanks, if they are after 1990, have 2 compartments. Single chamber tanks used to be the status quo until the early 90s. And that septic tank leads to a leaching structure of some kind. There are many different types of leaching structures out there. But the importance of your leaching system is actual treatment of the wastewater. The pathogens that are found in sewage and cause disease are filtered through the soil. So the soil plays a huge role in purification of the sewage. Okay. So generally, wastewater runs out of your house from a main drain into your septic tank. And the tank is a holding chamber to allow your solids to settle to the bottom and the fats, oils, and grease to float to the top. In a 2-compartment tank, after your solids settle out in the first compartment, what we call effluent spills over into that second chamber. The idea is for all of the solids to settle out and leave primarily only liquid entering that second chamber. From that second chamber, there's one final component, which is an effluent filter at the outlet of your septic tank, which is designed to trap any remaining particulate that did not settle out in the first chamber of your tank. After the tank, it leaches to your leaching system, and that is when the wastewater has an opportunity to percolate into the soil and remove that harmful bacteria naturally. So here's a cross section of a typical tank. From left to right, we have the inlet from your house, and then we enter into what's called a baffle. It's shaped like a T if you follow the blue arrow in. That generally slows the flow down and contributes to the settling in that first chamber. So again, all of your solids settle out to the bottom of that first chamber. There's a small baffle, usually about at the mid-seam of the tank, where it says water flow, and your scum layer floats to the top. So we don't want to end up with solids or fats, oils, and grease in your scum layer. So that's why you have a small baffle at the midline. The idea, again, is that in that second chamber, it's pretty much only liquid. And then we have another baffle at the outlet interior of the tank, which that is where the filter is housed, and that catches any remaining particulate matter before the effluent leaves the tank and drains to your leaching field. So the idea behind a settling chamber is to reduce the velocity of your wastewater discharge from the home or other building, and give time for that physical separation to happen in the wastewater. Materials that are heavier than water will settle to the bottom and form the sludge, and then your lighter materials will rise to the surface and form that scum layer. So oftentimes, if you're getting your tank pumped out, and you look at it when they remove those covers, it will be full, but you'll also see that layer at the top. It shouldn't cause a panic. It's relatively normal, as long as you're not excessively adding fats, oils, and grease down the drain. Then you should be okay. All right. So again, on the dual compartment tank, it's designed to improve the retention of your floatable and your settling solids. Again, second compartment allows for a reduction in the turbulence and velocity of incoming wastewater and catching any suspended solids that remain in that tank prior to reaching and potentially clogging the leaching system. Now you may think, okay, well, I don't have a 2-compartment modern tank. I have a single chamber tank. Maybe I should add an effluent filter to it. Actually, we don't recommend doing that. because inside of the tank, without the opportunity for proper settling, you could cause more problems. So filters are really only meant for a 2-compartment modern tank. The size of the tank is important, and in general, it is based on the total number of bedrooms in your building, in your house. If we're talking about a mixed use building that may have bedrooms and commercial, we would look at square footage and the intended use of that building in order to determine what your design flow is. And then your design flow will dictate how large your septic tank should be. So again, on filters, they're meant to protect your leaching system from premature clogging. We don't want particulate reaching the leaching system and potentially causing a backup. This is what an effluent filter looks like. I actually brought one in here in person, but we'll stick with the photo for our purposes here. But as you can see, this device drops down into that baffle at the outlet of the septic tank. So it's completely pulled out of that baffle in this photo. And it looks like the tank is empty. So it could possibly be a new tank or have just recently been pumped out. This tank also has a riser assembly on it, which is that green that you see. Those are required on tanks that are more than 1 foot below finished grade. So if the top of your tank is deeper than 1 foot below ground, then you need to provide a riser. So tanks provide different degrees of treatment to the wastewater. Aerobic bacteria provides a biological treatment that degrades organic matter in the presence of air or oxygen, and anaerobic is a lack of oxygen. It's similar function, but at a much slower rate. So oxygen is critical in the treatment of effluent and sewage. Here's another picture of a septic tank. You can see at the outlet, they actually wrote out, which is important in the field because you have a built-in 3-inch elevation difference from the inlet of your tank to the outlet of your tank. So where your sewer pipe discharges from your building, it enters the tank 3 inches higher than where that pipe exits the tank. So there's a built-in elevation drop across your tank. So it's very important to orient your tank in the right direction. Many times you may have a distribution box or multiple distribution boxes. They are literally that. They are boxes meant to distribute effluent, and they are installed following the outlet of your tank. So into the tank, out of the tank, and then you may have a distribution box prior to the leaching. So they function for serial distribution and equal distribution to your leaching system. Your leaching system may consist of multiple rows of a leaching product. And so a distribution box would be critical in getting that effluent received from the tank and sending it in an equal fashion to your leaching system so as not to overload one trench. Here's a photo of a leaching system with a distribution box. So as you can see, this pipe coming directly in from the center of the screen is following the outlet of the tank. It should be effluent only, no particulate, no solids. And then this looks to me like a level system. So all of the pipes that exit that distribution box and lead into each of those fingers of leaching row are set at an equal elevation. So they should all be receiving effluent at the same time when that box fills up. Over on the right in the corner over here, you can see a little yellow device that says DeWalt on it. That is a laser, And so when we're out in the field doing inspections of these systems, we actually take live elevations using a laser to make sure that the septic system is not installed too deep into the ground after we've identified where the groundwater table is. So here's an example of a modern leaching system. So there are many different types of leaching systems. We have a lot of proprietary products. There are some that are made from plastics, some that are stone and sand, others that are concrete. And the idea is we want to select the best product for the soil that we encountered on site. So some of the most common leaching systems are leaching pits, or what we call dry wells, leaching trenches, and leaching galleries. So this is an example of a leaching pit or a dry well. It's very similar to a cesspool in its construction. It is also very similar to a well, an old dug style well, shallow well, were often built in the same fashion. And again, this is an antiquated type of septic system. So this type of cesspool does not have a septic tank prior to it. So it receives absolutely everything that's discharged to it from the building. It's antiquated and not ideal. In a similar fashion, a dry well looks almost identical. These cinder blocks are not an approved product anymore. This is a typical construction that you might see, which predated the health code. The health code was enacted in 1982. So if you live in a home older than that, you may have this type of antiquated system. They're generally very deep systems, and they again, they don't really offer even distribution of that effluent once it does exit the tank and enter into that structure. The green in this picture is actually a modern septic tank that's plastic, which is an interesting and becoming more popular item because the installers, they're very lightweight, they're easy to work with. The only concern with them is buoyancy. So if it's identified that there's a shallow groundwater table, a plastic tank would really not be ideal. But if it's necessary because of restrictions for access, for example, then we'd have to put in buoyancy controls. And that usually means they'd have to anchor the tank to some sort of platform that maybe is a poured concrete slab below the tank, or another type of concrete form is the most common anchor that we'd see for a plastic tank. Though there are concrete tanks that have floated up out of the ground. So buoyancy is a major concern in areas of high groundwater when you are installing a septic tank. This is a drawing of a leaching trench. So it's a very small rectangular thing pictured here that would actually in reality be much, much longer. And you can see it has a layer of filter fabric over the top of it. And below it, it is maybe 12 or 18 inches of stone with a pipe on top of that. The pipe has perforations in it. So this is where your effluent, after it comes out of your distribution box, is flowing into this tank, into this pipe with perforations. So the effluent will trickle out of those small holes into the stone below. And that is where they have the opportunity to filter through your leaching system and then ultimately the natural soils below. This is an example of a leaching gallery. This is a plastic infiltrator. A lot of times when you say I have galleries, it may mean a concrete structure that is rectangular shape and with an open bottom. Those are a little bit more heavy duty and were common in the earlier days. They are less common now because more modern products offer a greater amount of effective leaching area per linear foot of system. So what that means is that when you have a certain, let's say you have a 3-bedroom home, you need a certain amount of effective leaching area to satisfy the leaching system size requirement for a 3-bedroom home. So with a plastic gallery, you may be given more credit per linear foot than with a concrete gallery. And so in the end, you wind up with a smaller footprint for a leaching system if you use a product that's rated more highly. So these plastic systems are becoming more and more popular because they are rated much higher than the older sort of, I want to say, old school type of systems, which dry wells are still very common. And, you know, a lot of houses that were built in the 80s when we had a major housing boom, they were built with dry wells as leaching structures. And that may predate the health code as well, because again, our health code technical standards for subsurface came about in 1982. So choosing a leaching system area, we always start with soil testing. Soil testing consists of generally getting a large machine. Somebody from the health department will meet an engineer or a licensed septic installer, or even sometimes a land surveyor on a property, and dig a deep test hole. And we like to get an 8-foot test hole if possible, because we want to know how much soil is available and the texture of that soil, the permeability of that soil, above any restrictive features such as groundwater or underlying bedrock or ledge. So if we go to a property and we perform soil testing, we're looking for an area that meets our separation distances and also has the best soil available for subsurface sewage disposal. If you have a private well and you're not on public water, you have to maintain a 75-foot minimum setback from your well to all parts of your septic system. So your tank, any distribution boxes, and your entire leaching system. We also want to be as far as we can from water courses. In Connecticut, that is a 50-foot setback to a coastal jurisdiction line, and a 25-foot setback from a water course. And especially with new homes, always thinking about future improvements. You know, if you want a pool someday, it's a good idea to design for it when you're thinking about upgrading your septic or installing a new septic. Sometimes during soil testing, we'll find impermeable surfaces impermeable soils. Impermeable surfaces and those areas that are subject to vehicular traffic should not really be the first choice for a leaching area. Although, you know, you can design for a septic system in an area that is expected to receive vehicular traffic. It's more desirable if another area meets all the separation distances and is available. And again, back to the permeability of your soils, we generally want a system that's not going to be in hard pan. So if we can find better soils all within the same parcel, that's what we strive for. So in our health code, we talk about receiving soil, which is the soil in the leaching system and around that leaching system, which is available to disperse your wastewater effluent. This is the soil that is going to immediately treat those disease-causing organisms that we talked about, which are found in sewage. So the characteristics of the receiving soil help determine the sizing of the leaching system. The more well-drained your soils are, essentially the smaller system would be required. So the other half of soil testing, in addition to that deep test hole that we talked about, which I touched on, are percolation tests, and which we call perk test. So a perk test is different than the deep test hole. It's usually a smaller excavation, and it's designed to give you an idea of how those soils which you encountered during soil testing in your observations of the deep test pit, and how they will drain. So what we do is we take after we dig the deep test holes and identify what our restrictions are, we then dig a perk hole, usually with a post hole digger. It's a very narrow hole, and we fill it with water first. That's the first step, to simulate soil conditions when they're saturated, like after heavy rains or during the wet season, every February to May. And then we let that drain completely. After that drains completely and the water has had time to come in contact with the potential silt in that soil, the silts will swell. And so it creates a more restrictive environment for water drainage, so that we can simulate a septic system and how it will function when it is under stress from natural conditions. So after we let that drain, we refill it, and then we actually take timed interval readings of that water drop. And that eventually gives us a rate of how many inches per minute it takes for the water to drop. Excuse me, how many minutes per inch of water drop it takes. So you may end up with a 10 minutes per inch perk rate. And that means that for each inch that the water dropped, it took 10 minutes. So the slower that perk rate, generally the larger the septic system would have to be. Of course, permeability of soils has a link to water quality, and it also affects our separation distances in the health code which we enforce. In this area along the shore, we have a lot of sandy areas. So your sandy soils, when you perk them, sometimes you can't even fill the hole with water because it drains so excessively fast. But thinking about that from a subsurface sewage disposal aspect, if you have your effluent entering your leaching system and then reaching the bottom of it where it meets the natural soil, if that natural soil is excessively well drained, then the effluent is just going to fly through it extremely fast, sometimes faster than 1 minute per inch, and it will hit the water table below much faster. So in those conditions where we have a perk rate that is faster than 5 minutes per inch, the separation distance increases for wells and for your elevation of the leaching system above where maximum groundwater was identified. So if during soil testing, the sanitarian witness test holes and declares that you have high maximum groundwater at its peak at 3 feet, that means you may only install your leaching system at 1 foot into the ground, 2 feet above that maximum groundwater. That's in a condition where you have a fast perk rate. If your perk rate is 5 minutes per inch, 5 to 10, then you're subject to an 18-inch separation distance. And it's anything above 5, to be clear. So anything slower than 5 minutes per inch, 10 to 20 minutes per inch, 20 to 30, and so on, you have an 18-inch elevation requirement between max groundwater and the bottom of your leaching structure. So we want to increase it in excessively well-drained soils to give the effluent more opportunity to filter through the natural soils. Does anyone have any questions so far?
I do.
Okay,
What is a hard pan?
hard pan, good question. Hard pan is a type of soil, the way I like to say it is when we're out doing soil testing and you have your shovel with you and you're poking at all the layers. And so, you know, sands are usually very friable. They fall right off the side of that hole very easily. Hard pan makes your shovel sing when you hit it. It goes nowhere. I mean, hard pan is like digging through absolute rock, but it's soil. It's typically, you know, a very compacted till type of soil. So it can be restrictive with regard to the downward flow of effluent because maybe you have a sandy soil above that hard pan. It's not ledge, it's still soil. You can dig through it with a machine or with a really strong arm, but it can impede that downward flow of effluent. So good question.
Another question. So what is the minimum depth that these systems can go in?
So what we're looking at is generally the restriction of how deep you can go. There isn't a minimum. Some systems, you have homes that, again, they were built prior to the health code and they don't have any soils available on site that meet our minimum criteria. So it's handled a little bit differently in that circumstance when you have an existing home that predates that requirement, because now today, if you were to build a home on a septic system, you have to have at least 18 inches of natural soil before you hit that groundwater table. So if you're in a circumstance where you have less than that, let's say, you know, somebody filled in a pond and built a house, you know, you have special requirements when your septic system fails. But there are pumps and other mechanisms in another chamber that follow your septic tank to allow that effluent distribution at a higher elevation if that's necessary. So if you have, again, groundwater at 6 inches and you have to be 18 above that, your leaching system is going to be out of the ground and you may end up with a mound in your yard. Those systems are a little more expensive. Thank you for that. All right.
Oh, one more.
Yeah.
Is there any specials, like you said, is 75 feet or 25 feet from a water course? And that's, I'm assuming, including the ocean.
The ocean is the coastal jurisdiction line, and it depends on the age of the property. So we have minimum of 50 feet. However, and it's the same for any water course. However, if your home predates August 16th, 1982, then you can reduce that separation to 25 feet. And the other important thing to distinguish here is that as regulators for the health department, we have the ability to grant a variance in certain circumstances for homes that need to replace their septic system that maybe don't have suitable soils or don't have the room to meet that minimum separation distance. So we can grant a variance for a reduction in a repair scenario only, not for any new construction. So yes, it's 25 feet minimum for a water course, and the ocean is the coastal jurisdiction line, which is 50.
And so if they couldn't do any of that, then they would be forced to do sewer.
Well, sewer is not available everywhere, so not necessarily. They would have to ask for variances, which we would all learn during soil testing what the particulars of that property are, and then figure out, okay, what's the best that we can do for this property? Is it going to be fully code compliant? Maybe not. Maybe we're not, maybe we don't have enough room to meet as much effective leaching area as we need. And then that would be reflected on the ultimate permit to discharge after the work is done. So for existing homes, you know, we work with what's available on site in terms of soils, and we do the best that we can do for that particular property. So any home, you know, you went and built in a swamp, you wouldn't be able to do that today. It doesn't meet our code. So it really only comes into play on existing homes that have a tough time or limited soils, where you're looking at variances. But it's not, you know, it's not a handout. It's an absolute last, you know, if you can't meet 75 feet to your well without going off of your property, then you apply for that type of variance. That's a different one. That's a very special one. That's only one that can be granted by the state department. Wells are very, you know, they're a water supply, they're a drinking source. So that minimum 75-foot separation can only be reduced if the state approves it. And then we have separation distance reductions that we can grant by variance for all the others. So to boundary line, to a water course, to the building served, we can reduce those to accessory structures, to pools, you know, if need be. Yeah, thank you. Thank you. All right. So moving on, receiving soil, phosphorus and nitrogen. These are the nutrients that must be removed from wastewater in order to prevent all kinds of environmental concerns such as algal blooms. And removal is achieved by using shallow trenches and maximizing time through the soil. So again, increasing that separation distance from the bottom of your leaching structure where effluent is entering the soil, and allowing more time and more soil profile for that treatment, that natural treatment, to remove those nutrients. So again, here's our 18-inch minimum soil that shall exist between the bottom of the leaching system and the highest groundwater mark. Bedrock is different. Bedrock is actually a 4-foot separation. So if you're out there doing soil testing and you hit ledge at 2 feet, well, now what do? We have to have 4 feet. So that would most likely be a pump situation where you're, you know, in addition to a septic tank, you're also putting in another chamber that has a submersible pump in it. And that pumps your effluent to your distribution box at a higher elevation so that you can achieve whatever your minimum separation distance is. So for bedrock, it's 4 foot. For most instances of groundwater, it's 18, but that can be increased if the soils are excessively well drained. Okay, so when we're soil testing, we look for groundwater, and we identify that with soil modeling. This is also called redoxamorphic features. Write that down, it's gonna be a quiz. No, I'm just kidding. So accurate identification of the groundwater table is really important because we want the leaching systems to function properly all year round. So if you don't classify that groundwater mark correctly, it can lead to a premature failure of your leaching system. And I think some health departments won't even do soil testing during some months of the year because of water conditions. But identifying that modeling line or those redoxamorphic features are what tell us, okay, this is where groundwater is sitting. It's the middle of August, it's a drought. We don't have any groundwater in this 8-foot hole. How do you know where groundwater is? Well, similar to the ring around the bathtub, you will get these soil colorations. They may be orange or gray. And what happens is as the water table rises and hits its peak for the year, it sits at that level and it oxidizes and it leaves iron deposits in the soil itself. So just like the ring around the bathtub, you know, we can see that actually in the soil, which is pretty neat. Here's a picture. The modeling in this photo is more gray as opposed to a typical iron modeling stain that you would see in other types of soils. So you can see here at the bottom of that arrow where it says 18, it's pointing to the gray. That's where high groundwater was indicated. And so 18 inches above that to the bottom of the leaching chamber is the minimum vertical separation that's required underground to protect groundwater when it's at its peak. So actually soil is amazing because it really can treat so much in not a lot of depth of soil. And I've done some readings on how they came up with the separation distances, for example, for a well. And they've actually learned that it's a far less distance before you have clean groundwater between your leaching and your well than 75 feet. So groundwater is purified at some point within that 75 feet. So 75 is conservative. You can feel pretty good about that if you have 75 or more feet between your well and your septic system. Your water's gonna, you have enough soil available for successful treatment of that water, of that effluent. All right, so getting into the meat and potatoes here. Common reasons for system failure, improper siting of soils or groundwater depth. Sometimes, you know, there may be a misread during the soils, and you know, that can cause trouble if modeling was missed and the system ends up being installed too deep, or there really was a restrictive feature that was misidentified, and that can cause, during the wet season, the leaching system to flood due to a misread in the beginning. Improper design, poor construction, maintenance deficiencies. Hopefully improper design and poor construction are being seen during inspections and plan review stages by the local health. Excessive water use or excessive food waste and grease. So again, you know, if you have a garbage grinder in your kitchen and you have a septic system, you really shouldn't use it. They're really not recommended. Your septic system is not meant to receive food matter. And you know, maybe you're thinking, okay, well, why not? I'm eating the food and it passes through my body and then it goes into the septic system. So what's the difference? But there is a big difference. The nature of how that breaks down is very different when you're just sending raw foods into the tank directly. Of course, excessive water use or excessive food waste and grease is also going to cause a problem. Grease, butter, fats, oils, they congeal and they solidify potentially in your discharge lines. So that can absolutely cause a problem. It can also clog your filter if you have a 2-compartment tank with an outlet filter. That and exceeding the useful life of the system. If you have a septic system that's original to the house and your house was built in 1950, bravo, good for you. But you know, it's probably time to look into this. I would imagine that the useful life of the system has ended. We have a question. Okay, Patricia, good one. If you have an older system with a good tank, can you replace the leaching field without replacing the tank? So this is kind of a yes and no. The key here is what type of tank you have. Do you have a single chamber tank or a 2-compartment tank? Many leaching products today per manufacturer will not allow effluent to be received from a single chamber tank. So There are products out there that you can install. Generally in this scenario, it does come up sometimes where yes, you have an older tank, maybe it's a single chamber. You need to, it's in good shape, but you need to replace the leaching system. So that does happen. So it's a yes and no. Yes, you can. The products that you are allowed to use are limited. And I always require that the tank be inspected by the company who's performing this potentially new leaching installation for you, so that they can declare, hey, we inspected this, we pumped it, the outlet baffles are in good condition, the tank is structurally sound, and once I have that, then we can look at a leaching only repair. Yes. Good question. Okay, so you have that leaky toilet that's always running. You want to address that if it's leading to a septic system, because those are the most common causes of system overloading. If you have a constantly running toilet or faucet or something like that, it just never gives your system the opportunity for a break. And these systems do very, very well when they have more opportunity for oxygen exchange. So oxygen is absolutely critical. You want that air to be able to reach and eventually, have a break. So you don't want water constantly flowing into your system. Systems that are allowed to rest for a short period of time generally will last longer for you. So a lot of times, maybe, we have a residence that's got a finished basement and there are a couple of rooms down there, and maybe they're using it as an Airbnb and the septic's old. It was only designed for a 2-bedroom. And it's just intensified the use of what that septic system was meant for initially. So overloading that septic system and using it and expecting it to support a higher design flow than what it was originally designed to withstand. Overuse of toxic chemicals that actually kill bacteria. So you have a very special environment going on in your tank. And all these products out there, that are advertised to solve all of your septic problems, and do this regularly, so you have a longer septic system lifespan. It's really not valid. We really highly recommend that you do not put additives into your septic system, because it really disrupts the environment. So the way I like to explain it is, if you're adding something with the hope of breaking things down, what really happens when that chemical enters the tank is it creates like a slurry, and it churns everything up in there. And so you end up with solids higher up in your tank, and it just doesn't settle out properly. So it really invites a disturbance of that environment and can potentially send solids into your leaching system, which will clog. And if you have a filter, it will clog even faster. So we highly, highly advise against any of those products that are out there. In some circumstances, you may have surface drainage that's not so successfully done, and not directed away from the leaching system, causing flooding. And then again, garbage disposals. Use a recycle a compost for those types of things, or just throw them into the waste, not down the drain. Septic tank not pumped, not watertight, or no outlet baffle. So outlet baffles are, thinking back to our cross section, are the T-shaped pipe that is on the interior of the inlet and then on the interior of the outlet. So when you don't have a baffle on there, it's just a wide open pipe. That's especially critical if you have a single chamber tank, because again, solids are just going to flow directly out of it and into your leaching system. So the best thing that you can do is routinely pump your tank, at which time the company should be opening up your covers, both inlet and outlet. If you have a 2-chamber tank, single chamber tanks typically have one manhole in the center on the top. So that would be their pump out location. But at that time, when they pump it out, they can give you an analysis of, hey, you have a baffle, or, maybe your outlet is deteriorating, and your tank is kind of crumbling a little bit, and it's no longer watertight. We're going to pause here for a couple questions. So yes, there is a pumping frequency. It is every 3 to 5 years in Connecticut. That is a recommendation. It's not enforced unless you're in a specific municipality that has an ordinance. For example, Old Lyme is a town within our district that has a pump out ordinance. And they require that you pump every at least 7 years. So the recommendation is 3 to 5, and an actual, they're the only ones I know about in this area that have an ordinance is Old Lyme, and they give you 7 years.
What about if you rent? Like if you're renting a property that has a septic system?
If you're renting, yeah, that's a good question. If you're renting a property that has a septic system, do you mean what is your responsibility?
Yeah, what is your responsibility as a tenant, or what is the responsibility as the homeowner as far as pumping goes? If the tenant has an issue with maybe flavor, taste, sickness, illness, stuff like that.
Yeah. So if you're in an area where there's not an ordinance, legally you are not mandated to pump within that 3 to 5 year window. However, it ultimately is the responsibility of the property owner. If you're living in a rental and you suspect that there's a problem and you say, hey, I'm gonna get this tank pumped out, you have to take that up with your landlord and say, here's the receipt, it cost me $350. I like to see the system continually maintained on a routine basis, and then kindly ask him to reimburse you. And did you have another?
Oh, I did have another one. So you said, you don't want to add anything, toxic chemicals and stuff like that, that can kill the beneficial bacteria, but are there any types of like special microbes that you could add that are safe to help the digestion of your system?
No, everything that enters a septic system that's supposed to enter a septic system, which is a much shorter list than all the things you shouldn't enter into your septic system, they create that ideal environment naturally. So there's no need for you to add really anything. What you want to do is avoid adding anything other than waste paper and human waste. That's it. Soaps are going to be generated, obviously. So, trying to dial that back, not doing laundry every single day, not doing dishes every single day, limiting those things can certainly help create a better, more successful environment. But I'm not aware of any septic system needing additional microbes. Even if you said bleach, you want to clean your toilets and you pour a bunch of bleach in there, that kills the beneficial bacteria in the system. So doing that on a minimal basis, I would highly recommend. But really, if you're conscientious, then there shouldn't be a need for you to introduce any type of external microbe or what have you.
That this question kind of goes along with that though. So do they have like new septic systems, or would this be okay or help? Or if like you had 2 separate tanks, one for gray water and then one for just, your waste?
Yeah, so that's a great question. The health code defines sewage, gray water as sewage. So
So what I would mean is like your sink, your laundry and all
Right.
that stuff go into one tank, And then like another tank would just be your toilet waste stuff.
Yeah, and some houses are set up that way. I like to call it like an old school thing. But it's, ultimately you're gonna go to the same leaching system. So you could put in a dedicated tank and system for your gray water. But it's not required. You don't have to do it. It doesn't
Help or not help.
Yeah, it's kind of neutral. It's one of those things where, if you're super environmentally conscious and you want to do this, just understand that gray water is considered sewage, and that means you can't just send it into a dedicated leaching structure. You have to provide a septic tank. And so for most people, that's not desirable. They say, well, if I'm going to have 2 tanks, I might as well just send it all into one. So the important thing there being that gray water is considered sewage, and it's no longer acceptable to discharge just your laundry to a dry well. You have to have a tank in front of that leaching structure, whatever it may be.
Okay.
So, but that was something that a lot of the older homes did have, and we're finding that they're finding these 2-inch laundry lines and what have you, kitchen waste lines, and they're all getting tied into the system, the main system that serves the whole dwelling. Because septics are expensive and most people don't want to put in one. So, putting in another one is just, you are spreading out in theory the distribution, but you probably have to have enough space to do that too, especially if, you're subject to separation distances, property lines, water courses, wells, buildings, accessory structures. So you'd have to have an ample amount of room for that to be ideal. Certainly there's nothing that prohibits you from doing that. And is it more environmentally beneficial? Maybe, because you're spreading out that flow across a larger area, but there might be other restrictions at play. Cool. Does that make sense?
Yeah.
Okay. And then when we're talking about a pump chamber, the incorrect float settings discharge at a high volume. So what that means is, if you are a person who's got a system that consists of a pump, a submersible pump inside a chamber, which follows your septic tank, and in theory is only receiving liquid, inside that chamber you have floats. There's an electrical component to power the pump, and there's typically 3 floats. One float is an activate on, so once the liquid level inside that chamber reaches that first float, it sends the pump into a cycle to discharge a certain amount of gallons to your distribution box and your leaching system. So if that float setting to activate the pump is incorrect, then you may end up with a chamber that's 3/4 of the way full before it kicks into a cycle. So keeping those float settings at a proper elevation is important in terms of not overloading your system. Some of these pumps are set at a certain discharge, so they will discharge, maybe 60 gallons at a time every single time they kick on. But that's all relative to the type of pump you have and the elevation at where that float sits inside the chamber. The other 2 floats are for alarm purposes. So if it reaches your top float, then you are in an alarm situation and you only have maybe 24 hours of storage available in that chamber. So best thing to do in that situation, especially if we're experiencing a power outage, for example, and you haven't had your tank pumped out in a while, you might want to get somebody out there to pump your tanks to buy you a little bit of time to get that pump checked out. So some common mistakes during design and installation, again, soil permeability. A lot of times in a repair situation, we like to have multiple perk tests, and we take the perk result that was the slowest. to design that septic system. The systems itself, as dictated by the health code in Connecticut, are subject to two criteria. One is MLSS, which stands for minimum leaching system spread. It's a length requirement. And the other is effective leaching area. So a square footage requirement based on the overall design flow of the building. So if the soils are overestimated or underestimated, then you can wind up with an improper design. Poor fill material or compacted soils. So compacted soils, this can be your hard pans, your natural soils, or the septic sand that is brought in. So we require in the state of Connecticut that a sieve analysis be submitted, which is a test that it's a permeability test of the septic sand itself. So it has to pass a certain gradation for permeability. It has to basically pass its own perk test, so to speak. So if you have soil or septic sand that's brought in and you look at the sieve analysis from the supplier and it doesn't meet our criteria, then you could have an issue there for sure. Again, misreading soils, uneven distribution, where you have multiple rows of leaching and maybe something happened in your distribution box and only one row out of 3 or 4 is receiving the effluent distribution. That row is going to tire very quickly, and it's not being evenly distributed to all of the rows. Excessive or poor quality backfill over the system or installed too deep, resulting in limited air exchange. So again, back to air exchange, and oxygen is very important in supporting the overall life of your septic system. So the health code in general encourages shallower systems. For depth, we have a maximum in our health code. You cannot exceed 8 feet into grade. And then failure to install trenches parallel to contours or failure to install trench bottoms level. So thinking about a trench at one end that's, maybe 75 feet long, that other end of the row should be at the same elevation as the row where it starts near your distribution box. And then trenches being parallel to contours. So if you're thinking about, you're sledding down a hill in the snow, you don't want one end of your leaching system at the bottom of that hill and the other one at the top of that hill. You want to orient it, 90 degrees so that your each end are at a same elevation along that slope or that contour. And then we have, for again, those folks with private wells, more increasingly we're seeing water treatment systems. In Connecticut, water has a high iron and manganese content. Just in general, many people are affected by high iron and manganese. And the most common treatment for that is a water softener. Now, if you have any concrete around your home and have made the mistake like me of putting salt down on those pavers in the snow or the ice, you will learn very quickly that salt just absolutely eats concrete alive. So being that most septic tanks are made out of concrete, if you have a water softener system in your home, you really ought to know where that backwash discharge line is. Does it enter into the main sewer discharge pipe exiting the building? And is that going into your septic system? If so, you want to definitely interrupt that and rectify it. That type of system, like your gray water question, a backwash from water treatment wastewater can dedicate just to a small leaching system for discharge. Doesn't need a tank, but that is the proper method of disposal for water treatment wastewater. Definitely do not want any backwash entering your septic system from a water treatment system. Okay, I have a little video for you guys, and then we can take like maybe a 5-minute break after this. Does that sound good? All right.
Don't buy solar panels. Seriously, there is a very good reason why we're saying this. If you're thinking about buying,
Your on-site sewage treatment system is a major investment.
Can you guys all see this? No.
It's just showing the, like, your slideshow.
Oh, all right.
We can hear it, but we can't see it.
Okay, let me figure this out.
Share. When you share the screen, yeah, share the video. There you go. Bottom left.
Thank you. Teamwork here. All right. How about now?
Yes.
All right, so this is not Connecticut, bear that in mind. A lot of things are similar, but this was just a good overall kind of video. So they talk about snow. I don't think we quite get as much snow as they do. I think this is Minnesota. So just bear that in mind as you watch.
It adds considerable value to your home. And just like your house, a septic system also needs to be properly maintained. Septic systems can and do fail, but most failures are preventable. Therefore, it is important to understand what can cause them to fail. Each septic treatment system is designed for a specific level of use. That is, each can handle only a certain amount of water before it becomes overloaded. The size of the system that is installed is typically based on the number of bedrooms it will serve. The number of bedrooms provides an estimate of the number of people who will be using it and the amount of wastewater they will produce. For example, a system designed for 2 bedrooms will handle a maximum of 300 gallons per day. If the actual usage is the equivalent of a 4-bedroom home, which is a maximum of 600 gallons per day, that could eventually result in the failure of the system. Installing the right size system and not overloading it is one way to prevent its failure. Excessive water consumption from leaky faucets, taking longer than normal showers, washing small loads of laundry with high water settings, or running a sparsely loaded dishwasher is hard on your septic system. Practicing simple water conservation like fixing leaky faucets, installing low volume shower heads, and replacing old high volume toilets with new low volume toilets will go a long way in preventing septic system failure. It also helps to wash only full loads of laundry and run fully loaded dishwashers. Spreading your laundry and dishwashing out over several days of the week will also help to prevent overloading your system. Another way to prevent system failure is to not use it for garbage disposal. Non-sewage items will clog or corrode your system. These items include, but aren't limited to, garbage ground up by a garbage disposal, coffee grounds, diapers, feminine hygiene products, paper towels, medicines, hazardous waste, and caustic chemicals. Automotive oil, gasoline, antifreeze, and other foreign fluids should never be disposed of in your septic system. Instead, take them to an approved collection facility where they can be properly disposed. Never put starters or additives into your system. There are enough bacteria in the natural waste that your system holds to keep it functioning properly. Additives are of no benefit and may even harm the system. Activity outside of your house is an important part of septic maintenance, starting with regular pumping in your tank. Typically, tanks should be pumped every 3 to 5 years. The actual pumping timetable depends on the level of usage. A family that uses lots of water for showers, laundry, and dishwashers will need to pump more frequently. You should be aware of where the system and all of its parts are located on your property. A review of the permit should assist you with this. Protecting your septic system's drain field, tank, utility lines, and expansion area is extremely important to maintaining the system's health. Do not drive or park on your septic system, including the expansion area, as this will compact the soils. Do not construct walkways, patios, swing sets, or buildings on the septic system or expansion area. These areas must be left for the sole purpose of waste treatment. Rain and snow runoff must be directed away from the septic system, and you should make sure that good stormwater management practices are being followed. Having grass on your system will serve as an insulation in the winter and preserve the ground cover, but keep deep-rooted trees and shrubs away as they can interfere with the system's drainage. Preparing your system for winter is another way that you can protect your system. Spreading a layer of mulch over your system prior to the first snowfall will help insulate it and keep it from freezing. After the snow arrives, do not compact the snow, as it loses its insulating properties. Snowmobiling or feeding deer on the system can compact the snow enough to cause a freeze-up or serious damage. Septic systems are very expensive to replace, but damage can be avoided by adopting good septic system maintenance habits. It's a good practice to keep all of your records pertaining to your septic system in a safe location, including your permit, site plan, pumping records, and repair logs. This will help you locate your system, identify the type of system you have, its capacity, and when you may need to schedule service. With proper use and maintenance, your septic system will work well for many years so you can enjoy your property and protect our natural environment. The St. Louis County video series provides additional details regarding property development. The county also has printed guides and other information available.
All right. So Missouri, not Minnesota. All right. Is this showing now?
Still showing Zoom,
Okay, hold on.
that white screen.
Oops. Hang on, guys.
Stop sharing.
Oh, you sure?
Yeah, there you
All right, we should be back now to the right screen. So we have a couple questions.
So what do you think about putting a greenhouse over a tank?
Oh, you can't do that.
You can?
No, you cannot.
But it gets really warm though, like.
What, to protect it from the heaps of snow that we get here?
Well, I mean, it would keep the greenhouse warm, no? Like,
Yeah, you know, in general, you don't really have to worry about freezing. Are you thinking about the system freezing?
no, just like that it would keep the greenhouse warm, and so.
Oh, to keep the greenhouse warm.
Yeah.
Oh, not to protect the septic system.
No,
Okay, okay. Oh, we still can't do it, sorry.
Okay,
When you apply for a building permit for your greenhouse, which of course you would do because it's gonna be legal, we have to review any septic, any properties that aren't served by a septic system to make sure that whatever your project is, it either is, it meets the separation distance, which a greenhouse is an accessory structure. We have a 10-foot setback for that.
okay.
If you're adding bedrooms or a living addition, that, you know, we are comparing what you have for a septic system versus what the increase in, you know, what the intensification is going to be on the existing septic. So if you are applying for any building permits and you have a septic system, the health department is going to look at that. And we don't want you putting any structures on top of your septic system.
Okay.
So no structures on the septic.
How far should a vegetable garden be from the field?
Oh, good one. Before I was in this field, I unknowingly put a vegetable garden right on top of a leaching system. I'm fine, but
Probably
or am I? I don't know. Here I am on Valentine's Day talking about sewage. No, I'm just kidding, guys. So that's a good question. I don't know that we don't have a declared separation distance as to what's safe for, you know, your vegetable garden. But typically, you know, I would stay like maybe 10 feet. That's not an enforceable thing, but if you have at least 10 feet and beyond, I would probably try to maintain that. In theory, your effluent is discharging below the ground and probably lower than where your root structures from your vegetables are going to reach. They tend to look for, they're looking for underlying water, which, we have our separation underground from the bottom of the leaching to that max groundwater table. So it's possible that your roots could extend in that same zone. So I would say maybe, a 10, 15 foot buffer, you're probably safe.
Okay.
Yeah.
Can
Just
you
your-
plant plants around your leaching field to help uptake the nutrients from your leaching field?
You just want to be careful. You don't really want to have plants or anything that's largely rooted because the roots create a problem. So really, you don't want to. You kind of want to keep your leaching area clear of pretty much everything. You could put like a surrounding, some of these small
Grasses.
native grasses and so forth that don't have a dense root structure that'll interrupt, your piping or clog things, because those roots will find that effluent and they will enter that perforated pipe and they will clog it. So you want to be careful with that. Good questions. You're challenging me here. It's good.
We have another question. It looks like from Rick. Sea level rise, major and more frequent precipitation events will most likely cause the water table to rise, which may cause systems to fail. How will towns deal with this?
Good one. We have already seen septic systems impacted by surges of storms. Sandy is a good example. Actually, we had along the shoreline, so much sand blew, some natural sand blew away and exposed these systems during that event. And it was really concerning. They've been flooded, and what is the resolution here? Should we be worried? Generally, from what I've seen, is that these systems, once that water level drops significantly back, closer back to where it was prior to that surge, they recover very well, which is great. We are looking at increasing our minimum. Actually, we just had a revision to our technical standards, which is our regulations that govern the enforceable requirements for septics. And this was a discussion on the table as to, okay, we have an 18-inch separation. Maybe we just jump to 24 as a blanket requirement across the state in anticipation of more intense events and these surges happening more frequently. For now, it's tabled. We already do have a mechanism in our code that allows an increase, or it requires rather an increase to 24 inches from, again, bottom of leaching to max groundwater in coastal areas. So if you can set standpipes and determine that a property is tidally impacted, then you're already going to be subject to a greater increase above max groundwater than the 18 inches that's currently a minimum. So moving ahead, I think, the state is trying to stay ahead of that. And although it didn't get implemented yet, it is a discussion that is very alive and happening. And so I think regulation changes in anticipation of these events are going to be how the towns and districts go about anticipating these things. So hopefully that answers that question.
Looks like it for questions right now.
Okay, awesome. So these are just some links for you guys. Write them down. This is a home buyer's guide to septic systems that comes directly from DPH, Department of Public Health for the state. And then we have another one on basically septic systems 101. This is, your own maintenance. It's a lot of the things that we've touched on tonight in how to properly care for your septic system. And then, of course, if we get this recording publicized, you can always come back to these documents. This is another link from EPA. Every week we have, every year we have a Septic Smart Week, which is just trying to reach those audiences with regards to proper care and maintenance for your septic system. For especially home buyers, although buyers are becoming more and more aware, researching, figuring out where the septics are, getting them inspected. We had a lot of real estate transactions throughout the COVID-19 pandemic, and septic tanks became almost a boilerplate item for every house that was sold over the last few years. They, seems like every single one of them got a new septic tank. So the only concern I would have, if I were advising my friend who is buying this house and getting the tank replaced, is that you want to perform soil testing and have an analysis of those soils, because if you replace a tank and then you set it at the same elevation and your soils have a high groundwater table, then you may wind up with needing a pump system where perhaps gravity was attainable, and that tank, replacement could have been raised up a bit to anticipate a potential leaching repair somewhere down the line. So, that's not a requirement. Soil testing is not required for a tank replacement, but it's also beneficial because, again, going back to buoyancy, if we have no data on your soils on the property, and groundwater is a potential concern, we may not realize that going into a tank replacement. So that's something that property owners and potential home buyers should absolutely be aware of. Again, this is just what is outlined in that link. Do we have another question? Oh, wait. I think we have another question. Okay. Apparently there are good regulations for new septic system construction. What about monitoring and regulation of systems that are 40 to 60 plus years old, especially those bordering freshwater lakes? Yeah, so if you have a system that is malfunctioning or failing, that is a critical condition and it's classified as a public health nuisance. So you'd want to call the health authority, the local health authority, if you know about a effluent breakout on the surface of the ground, or if your neighbor said, God, my septic system, it's been backing up in the house. Obviously this is a sign that the system is not functioning correctly. So although we don't have a monitoring program or a regulation of systems that are currently in operation, certainly if you have a really tall, bright green patch of grass that's super lush every year, that suggests there's probably an issue with your septic system. So if you know this is occurring, be proactive, let the health department know, and we can jump in and take action. To us, a septic failure is very specific. So if you have a septic company that comes out and says, oh, this system has failed, that may mean something very different to a septic installer than it does to the health department. A true failure by health code definition means that there is sewage or effluent breaking out onto the surface of the ground, that we have the authority to jump in and cause abatement of that nuisance. Good question, very good question. So just education, encourage, especially if this is someone that about that's not your own personal self, just say, hey, this can really impact a direct runoff into a lake, a lake community where you're right on the water, and there's no benefit of true filtration into the soils, and there's an avenue for sewage to leach directly into those water sources. So our best resource in order to jump in and help is being made aware of these situations.
Do you wanna read that?
Yeah, so I think it's visible to everyone. Eastern Long Island has a grant program that helps pay for upgrading septic systems to help improve water quality. Any plans for a similar program in Connecticut? Are you aware of anything? Do you want to take this one?
So it would be like, if we would apply for a grant and help like the towns and the cities try to implement stuff like that. But I think it's just more along the lines of whoever applies for grants would get them, and as long as that's what they wrote for their proposal, you know, so it's like just based on.
Yeah, I mean, I think for that to come to life in Connecticut, and I'm not aware of any programs like that yet. You probably would have to have a significant area or community to demonstrate that this is occurring.
And their willingness to want to change it and fix it, yeah.
Exactly. On a case by case basis, we can intervene, you know, again, if your septic system's failing truly by health code definition, we have the ability to issue a public health order, which is a legal order to correct this problem. What about Long Island Sound grants? Yeah, I mean, I think you'd have to have a collective community of willing folks and somebody to write the grant application. And these grants do take quite a while to come to fruition. So it's a great theory, though I'm not sure immediately.
It's definitely not an immediate like fix. It does take several years to acquire something like that and complete it in full, so.
Yeah, I concentrate a lot of my work on the day-to-day in East Lyme, and there's a community along the shore in the Black Point area where it's all septic still, and I'm learning development where maybe on a septic system it otherwise wouldn't be possible. So you know, that's something to consider too. It's really an education thing in order to have your septics functioning properly. But you know, a lot of folks will turn down a sewer even though it's theoretically more cleanly, I guess. Or just less opportunity for issues to happen because it's one pipe leading to a main. But you really have to get these communities on board.
Is there an issue maybe like, are you not allowed to have a well if you are connected to sewer?
You can have a well if you are connected to sewer. There's nothing that prohibits you from that. It's a little less common. In my personal opinion, I think that if you have a well, you should have a septic. If you have a public water line, you should have a public sewer discharge. From certainly an environmental standpoint, to me, it seems like if you're taking water from a well and you're withdrawing it directly from that property, you should be restoring it right back on that same parcel. But that's not always the case. And there's no requirement one way or the other. And some communities are all septic but have public water tie-in. So each property is unique in that, you know, it's not set up the same way, and there really aren't any restrictions. I mean, maybe the water line became available and folks are in the process of abandoning wells. I know that Old Lyme, again, you know, is a great example because they are in the process of extending their public water, and they're requiring in these tiny beach communities where everybody's on a really small property. Listen, you have to abandon your old well in conjunction with tying into public water because everybody's still in a septic system. And you know, even in your own home, if you have to replace or repair a component of your septic, but you can't get 75 feet from the neighbor's well, you need the state to grant you a variance for that. Even if they're just keeping it for irrigation purposes, it's still an active open column directly to the water table. So you can't have that within 75 feet because it could potentially get contaminated by the neighbor's septic system. So there's a lot of different circumstances that come up, but you know, from an environmental standpoint, if I was in charge of everything, I would say, if you have water, you should have sewer, and if you have a septic, you should have a well, and vice versa. I used to live in a house that was on sewer, and I had a shallow dug well. It was 14 feet deep. It was an old farmhouse, and it was a lake community. And in the 80s, they brought the sewers in, hoping to improve the water quality of the lake. But I think and of course, there's no proof of anything, but again, in my mind, I'm thinking, okay, I'm withdrawing water from the table that's right here. And then where is it going? I'm sending it out into the street. It's going to a treatment plant. And then eventually, it gets treated and discharged to the Connecticut River, far, far, far away from here. So it doesn't give the opportunity for natural filtration of the groundwater table, as you're just sucking it dry. There's no recharge, exactly. So certainly there's room for improvement all the way around. But how do you go about that? That's the challenge, right? How do you can't mandate somebody to tie in if the town or the municipality doesn't require it. Some municipalities do, and they say, hey, we're running a sewer line and you have to tie in. Waterford's a good example of that. They do require that you tie in where sewer is available unless you have a true hardship, and they list specific conditions in which you are allowed to have. There's like 3 properties in the entire town that there's sewer in the street, but they are on a septic system due to ledge or other conditions that they're up against. So it's definitely an interesting discussion, that's for sure. And I don't think we're quite there yet, but the discussions are being had, so that's a good start. Okay. All right, and then most importantly, how your septic system can impact nearby water sources. So again, this is all the EPA Septic Smart discussion. So how do you know if you're on a sewer or a septic? You want to visit your town hall. Most of the time, the building department is going to be where you'll find these records, or you can check with the municipal water or sewer utility or commission for public connections. They can generally verify that you are connected because they will bill you every month or quarterly or however they do it. So they have a meter of some kind that will tell you your water use, and then they charge you accordingly. So you probably already know. What do you do if there are no records? Yeah, so this happens, believe it or not, it does. And I usually am in the process of reviewing something for a building permit, and they want to build a pool, and I say, well, I have absolutely no information on your septic system. And they say, well, I'm on a septic system. I've lived here for 40 years. And I'm like, oh my God. So you've never pumped your septic out? No? Okay, great. Well, it's time. And so what you can do is enlist the resources of a local septic company. They have cameras, they can do, a flushable locating device. You can try to do things yourself to start, go down in the basement and check out where your main drain line exits the foundation. That should give you an idea. And then a lot of those concrete tanks, they have rebar handles on them, so they might be detectable with a metal detector. And then your best bet is really going to be call a septic company that has the ability to camera your system, and then they can locate all of the components, what your septic system consists of, how big it is, and so forth. And then just again, coming back to the development of a property that is on a septic system, which we kind of talked about. So we evaluate what you've got there for septic currently, how that is going to be impacted by what you want to do, whether that's building a deck or a garage or a pool, or putting on a second floor, adding bedrooms, adding bathrooms, things that are going to limit your septic repair area or increase the load that septic system is receiving. In general, if you're not, so let's say, for example, you have a 3-bedroom home and you want to add a 4th bedroom, am I going to have to make upgrades to my septic system? And the way that Connecticut has it written in their regulations is such that as long as you don't exceed 50% design flow increase, then you don't have to make an upgrade to your septic system if you're increasing the design flow. However, you would need soil testing to be done, or soil test data that might already be on file, so that we can analyze and look at that data and say, okay, we're adding a bedroom. We're now looking at whether this property can support a septic system that's sized by today's standards for a 4-bedroom home. And here are our soils. This is, the general site map of the boundaries and how much available spread there is. And from there, we make a determination of approval or denial of that building permit. B100A is the regulation with which we, regulate these building permits when they come in. So if you are in a septic system and you're doing projects and you apply for a building permit, you should also be given a B100A. We're going to ask similar things. We want to see a site map that shows any existing buildings, what you're proposing to do, where your well is, where your septic is, and we're going to make sure that your new garage is the proper setback from your septic system and all its components, and that you're not putting it on top of your septic system. You don't want to do that. And then new construction. So this just being, I think we covered this, being that everything for a new septic system, new construction, has to be 100% code complying. So really you only run into the circumstance of a variance in an existing condition. There are absolutely no variances granted for new construction. You have to have 18 inches minimum to the groundwater table, at least 4 feet to underlying bedrock, and you've got to meet absolutely all of the separation distances. If you can't, then you're going to have to maybe downsize, build potentially a 2-bedroom, or if you're in an area and you've inherited the family land that's been passed down from generation to generation, and it's a swamp, and the sewer is not available, then I'm very sorry. I have to have that conversation with some people, and I feel bad, but until sewers are available, there's really I can't. A wetland is not approved for sewage disposal. So we do have a decent role in protecting and making sure that water quality at the end of the day is protected. The beach water program. So this is my favorite part of my job. I run the beach water program for Ledyard Health District. We have 45 sample sites that we monitor from Memorial Day to Labor Day. Every summer, once a week, we are testing the water for bacteria. And certainly the relationship between bacteria and water and public health is definitely significant. So if we have a freshwater versus a marine water sample, there are different thresholds for bacteria on what we would potentially post a swimming advisory or a beach closure. So actually, interestingly, the threshold is a little bit higher in freshwater than it is in marine water, and mostly I believe that is due to the turnover rate. Inland bathing areas they don't have the opportunity of tides. So it takes longer for the water to turn over. You may see in some areas these fountains that they have in fresh waters. Those are becoming more and more common because number one, they introduce oxygen into the water, and they also help contribute to the turnover of that water. So that will provide more even temperature of the water. Higher temperature water is generally a better environment for bacteria growth. And so when we have a high bacteria result in any of our swimming areas, we are on the ground right away posting swimming advisories and then taking another sample so that we know exactly when that bacteria level drops and when it would be safe to resume opening up the beach and people going in for a swim. Also, we're trying to improve our response to storm events because what we're seeing is that in a storm event, it's pretty much a blanket thing. Bacteria rises in the waters. Things get churned up. There's a high amount of surface water runoff in these events. Areas that aren't as successfully drained in terms of your street catch basins, that can contribute. Or there's a lot of impervious surfaces. Maybe you're in downtown New London, and there are many streets and less opportunity for that water runoff to hit a soil type of barrier and infiltrate into the ground naturally. And all these things affect water quality. So we are boots on the ground in the summer from Memorial Day to Labor Day out there testing the water at least weekly and closing these swimming areas. The concern with regard to public health is primarily for pets and for children because they ingest water more so than anyone when they swim. So that would be a direct mode of infection for bacteria to enter the body, and it can cause some really unfun side effects, mostly stomach upset and lower GI stuff. So
Surfers are okay then if they want to go out when there's just sparkling.
yeah, they're doing that at their own risk. I mean, some people ask me, I always get this question every year, what's a swimming advisory? What does that mean? Can I go in? And it's like, well, okay, we're not telling you not to swim, but we're just alerting you that we detected bacteria here. It exceeds the threshold in Connecticut. We have drawn a resample. We're waiting for results. Yes, you can wade into the water. I would recommend that you don't submerge yourself and rinse off after you're done. But everything, of course, is at the risk of the individual. So what we're doing is communicating that, hey, we have received this result. The lab has reported to us that it met the threshold and above, which is not good. And so while we wait for a clean sample, the beach will remain under advisory. A closure in our district means that we have had at least two positives in a row. So we don't move directly to closure unless it's following a storm event. So we're trying to improve our response. Every year we try to improve our response and our communication to our constituents. But severe storm events seem to be happening more and more. So I'm trying to improve our response to that. Last year was the second time I've done a district-wide closure in response without sampling every location. And it was tough. I mean, I was answering like hundreds of phone calls a day, so not everyone is happy. Everyone loves their beaches if they want to swim. So, all right. And then this is just an overview of everything we've talked about. So best management you can do for your septic is a routine pump out. Absolutely. That is the best way to know how your system's functioning and whether any repairs may be looming. Addressing any plumbing fixtures that may be leaking or running. Do not discharge miscellaneous items to your septic system, including additives that are broadcast to improve the environment, avoid them. Don't use garbage grinders, and think big picture. So meaning that, you know, in the long term, to have the most longevity from your septic system, you know, you want to think about everything that we've gone over tonight. So I think the biggest thing, which is the easiest thing that you can do, is just get your tank pumped out every 3 to 5 years. You may be on a more frequent schedule than that. Your pumper should be communicating that to you. If you have more people living in the home, you're probably going to want to pump out more frequently. You still, even if you're living in a home by yourself and you're on a septic, you should still stick with that 3 to 5 year window. So that's it. This is me. I am a senior sanitarian with Ledyard Health District. I am a registered environmental health specialist, nationally certified and licensed, and I'm a registered sanitarian in the state of Connecticut. So if you ever have any questions, here's my phone number, my email. Feel free to reach out to me anytime.
Thank you so much, Danielle.
You're welcome. Okay, so can you guys all see me now?
Yes.
Oh, good. Hi, everyone. Anyone have any questions?
No, thank you, Danielle. That was very informative and a very good presentation.
Oh,
Thank you.
good. I'm glad. You're welcome.
Thank you.
You're welcome. All right.
All right.
I guess we can close.
Sorry, we're gonna get all the candy.
Yeah, we have plenty of chocolate for you guys, but nobody came to see us in real life, so we'll just have to eat it all ourselves. Happy Valentine's Day. Thanks for talking about sewage with me today.
Have a good day, guys. Thank you so much for joining us.
Good night, everyone.